we are moving on to solving systems of equations with word problems, okay? It's a little bit tricky solving word problems because first off, we've always been accustomed to seeing a word problem and feeling confused right away. We're like, holy, all these words, I don't get it. And there's a process. You just gotta kind of hunt out certain words and relationship. Remember your vocab words for like sum, product, more than, all of that stuff you have to keep in mind as you create these word problems. There's 3 little steps to do, but it's not concrete. Every word problem is different. So it's not like solving a numerical system of equations through substitution, because those are concrete steps. Variable by itself, plug into the other one, solve, go back to where you put parentheses. Word problems are never concrete. Every single one of them is always different. So the first thing that I always do is define variables. That means let x equal something and let y equal something. That's always the first thing I do. Always. Any word problem. So that is concrete. You define 2 variables. This is the hard part. Make the 2 equations. You just have to be cautious. Keep your eyes peeled that there should be 2 equations. So maybe box off the 2 because you're going to be given 2 relationships. And you're going to have to set them both up and then solve. And now when I go to solve, you have to remember you're solving a system. So there's an x and a y. So when you solve the system, it is more advanced algebra because you have to make sure a variable is isolated, plug it in. So maybe you could even write that when you solve. Make sure a variable has a substitute. Do you know what I mean by that when I say has a substitute? That means like y equals x plus 2. So like y would have a substitute. And sometimes we have to find the substitute and then you go along and solve. I'm going to assume you know that next step. And that's where you have to be so careful with your integers, because integers can be a stinker sometimes with this stuff. All right, let's apply it. So the larger of 2 numbers is, okay, here's something that's concrete, the word is. Is means equals. So right away I know that this is going to be equals 11 more than twice the smaller. So I know that. Is means equals. Maybe even write that. Is means equals. The sum of the numbers is, there's another one, is 1 less than 7 times the number. Find the numbers. Step 1, define variables. Let x equal, what do you want? X big or small? I already wrote the s. X is small, y is big. It doesn't matter what you define as long as you just keep that in mind after you solve. Okay? So x is the small number, y is the big number. Step 2, create my equations. This is the step that's going to stress you out. It's not concrete. You have to just remember math vocab words and that you're looking for 2 equations. So the larger of 2 small numbers, so that means y, is 11 more than twice the smaller. Smaller was x. So it's 2 times the smaller, 2 times x, plus 11. Yep. Now I'm on a hunt for another equation because you should always have 2 equations. The sum of the numbers, so sum means add. So x plus y, the sum of them, is, so that means equals 1 less than 7 times the smaller. Remember, less than means less important. It's so mean to think of it like that. But less than is less important. You put it second. So you go 7 times the small number, x, subtract 1. Let me extend this page. And now I got the hard step over with, kinda, just kidding. It's all pretty intense. Y has a substitute because y is all by its lonesome. So the substitute scoots on down to the other y. Remember, when you get a substitute, the variable disappears. Like pretend that y was me. If I get a substitute, I do not stay here anymore. My substitute comes in for me. So I get x plus my substitute, so 2x plus 11. Notice I didn't keep the parentheses. I only keep the parenthesis if there was a coefficient in front. So I knew I have to distribute. So if I know I don't have to distribute, I just disappear. I let my parentheses disappear. So I would only keep the parentheses if it was like that. Let me show you. I would keep the parentheses here. That I would keep them because I'm going to distribute the 2. I would not keep them. Okay. So there I would keep, and then if it was y equals x plus 1, y plus x equals 2, I would not keep them. Okay? So this is keep, not keep. And the reason I wouldn't keep them is I would keep it because I need to distribute, because there's a number in front. So that's kind of tricky when there's not a number in front, like, what am I supposed to even do with this parenthesis? Okay. Equals 7x minus 1. Now I'm going to solve. Combine my x's, and I get 3x plus 11 equals 7x. I'm going to go ahead and multitask, right? Plus and negative 1. And then we typically move the smallest x, so I will subtract 3x. So I get 11 equals 4x plus a negative 1. I am almost done. I'm feeling good about this. I get plus 1 to move my 1 over, because my goal is to get my variable alone. 12 equals 4x. X equals 3. The first variable is always the hardest to find. Now what does that mean? That means that's my small number. So my small number is 3. Now what the goodness is my big number? Well, we go back to the beginning, where you put parentheses. So my large number, can you even see? My large number is 2 times 3 plus 11. 6 plus 11, 17. So you would, final answer would be your small number is 3, your large number is 17. Found it. That was easy. Wasn't that so easy?
Yeah.
Just kidding, that wasn't easy at all. I know that's not easy. Okay, let's set another one up. I like these ones. These kind. The cost of admission to the spring carnival is $39 for a group of 8 kids and 3 adults. The admission was $43 for another group of 11 kids and 2 adults. What was the admission price for each kid and adult? So the two things I'm talking about is kids and adults. So I will let x equal kids, y equals adult. Again, the goal here is to create the 2 equations. So you should be able to identify 2 relationships. The cost of admission was $39 for 8 kids and 3 adults. That means 8 kids plus 3 adults equals $39. The admission was $43 for a group of 11 kids and 2 adults. So 11 kids plus 2 adults equals $43. I'm not going to solve this one. This one is elimination. I can't find a good substitute, notice. So I can't solve this. I can, you're not there yet. Okay? So, but now you are seeing defined variables set up. That is important for today. So as far as the process for this one, you learn that on Monday. So we're scooting down to the next one. Moolah, get it? Moolah, like money. Moolah. That was so witty. Moolah has 27 coins that are all dimes and quarters. The value of the coins is $4.35. How many dimes and how many quarters does Moolah have? So, looks like I always need to do the concrete step of step 1 and define my variables. Let x equal, I'm going to say dimes, and let y equals quarters. Okay? Moolah has 27 coins. You want to know what that looks like? That means dimes plus quarters equals 27. That's what that means. The x plus y is 27, because I have 27 total coins. Now I'm on the hunt for my second equation. The value, so that's the money. I always put the value one on the bottom. So I put like the sum as my first equation, and the value one I typically put on the bottom. The value of the coins is $4.35. So now I have to define value. Well, dimes is 10 cents. 10 cents times my dime plus 25 cents for each quarter, 0.25y, equals my total amount, which is $4.35. So I set up the two equations. I can solve this one because I can easily find a substitute, so you have everything you need for this one. I'm just going to subtract my x over and get y alone, since that's what we typically do. And you get y equals negative x plus 27, right? Can you see that? 27. Found my substitute. And now my substitute goes in for the y on the opposite side. And I have 10 cents for each x plus 0.25 times y, but y got a substitute, so y isn't there anymore. Negative x plus 27 equals 435. Calculator's going to be your friend with this. So I'm going to distribute 0.10x plus negative 0.25x plus 0.25 times 27 is 675 equals 435. Combine like terms. And that's negative 0.15. I knew that. I should have believed in myself. Negative 0.15x plus 6.75 equals 4.35. Now you might be saying to yourself right now, that doesn't even make sense because we're talking about dimes. How many dimes and nickel quarters do I have? How can I even be negative dimes? Well, just you wait, it's going to turn positive because I see that it will get negative over here. Minus 6.75.
It's going to be a flat number.
You sure about that? It's got to be, honestly. 4.35 take away 6.75 is negative 2.4. Divide it by a negative 0.15 and you get 16. That means I defined x to be my dimes. So my dimes are 16. And then I go back to my first equation, and you can even just use this one. Oopsie. So I know that I need a total of 27, right? 27
Yes.
dimes and quarters. So then my quarters are 27. Take away the 16 dimes that